ஹலோ மித்ரா.
ஹே கார்த்தி, நம்ம நம்ம ரொம்ப நாளா இந்த டுட்டோரியல் செஷன் எடுத்தும் ஆச்சுன்னு நினைக்கிறேன். ஸோ லாஸ்ட் வீக் வந்து வி saw few of your examples and I think we discussed about time series and stuff like that.
Yes,
இப்ப அது
yes. Okay, we are continuing on this journey of trying to predict the forecast the stock values. இல்லையா?
கரெக்ட்.
ஆமா, we are into part 3 now. Last week வந்து the trend, seasonality and residuals பத்தி பார்த்தோம். Where you can look at the trend of a stock and then decide, and we look at residuals and seasonal, what are the values சொல்லிட்டு. Probably can follow the book, it's easier. The book is this book, at least by let's maybe give some by Marco. It's really a good book. But இது வந்து ஆக்சுவலா கொஞ்சம் கச்சமுச்சா நிறைய எழுதியிருக்காரு ஆக்சுவலா. But you can skip a lot of these things easily. But for you want to do some real practical examples, it's really good. Okay. So what is moving average? See, before moving average, going to moving average, actually, I want to talk. Maybe you can come to it later. So this is the moving average. Moving average is something in which your predicted value, the value, current value depends on the mean and the previous error terms. இதுக்கு ஒரு ஆர்டர் இருக்கு. Q is the order. For example, previous n terms, how many terms you want to look at, that defines the value Q. அதான் ஆர்டர்ன்றது ஆக்சுவலா.
Okay.
Look at only one. Yeah, go on, Nityan.
So y of t is equal to mu plus epsilon t plus theta 1 epsilon t1 அப்படின்னு சொல்றாங்க. What are those terms apna?
Okay, the current value yt is a combination of mu, which is the mean of the whole data, then the current error term, and then the previous error term with some weighted function theta 1, theta 2, blah, blah, blah. Yeah. இதுக்கெல்லாம் கொஞ்சம் weight கொடுத்துரும். The previous error terms we give some weight. For example, our process, let's say MA1, the current value is mean plus the error term, current error term, plus some theta of some previous error term. Last கடைசி இருக்குல்ல, previous value ஓட error term.
ஆமா.
Okay, it's a combination.
Okay.
So similarly, we can expand to MA2, MA3, whatever you want. Okay. It's funny anyway. I think that's what we are. See, this Sarimax, we are trying to go from MA, then we'll go to AR, then Arima, Sarima, and Sarimax. That's primarily what we'll follow.
Okay.
It's very good. Technology ரொம்ப நல்லா ஒர்க் பண்ணுன்னு நினைக்கிறேன் நமக்கு. Okay. So before we start this, I want to just put some placeholders. எப்படி நம்ம வந்து நிறைய பேருக்கு AI ட்ரைனிங்ல வந்து சும்மா பேசிக்ஸ்லாம் கொஞ்சம் செட் பண்ணிக்கிறோம். Usually you get a data, you split the data into some 80-20% for training and then testing. Yeah, that's what we're going to follow.
Correct.
I think maybe it's here. Okay, sorry. So this simply வந்து, for example, this data, we're going to set it to train data and test data. We can use this some of formula, which 120 is maybe last 2 quarters. 5 years data வந்து 120 க்கு வந்து last 2 quarters வந்து leaving it for testing. Every other data we use for training. அது முதல்ல plotல பார்த்தோன்னா இன்னும் நல்லா புரியும். ஓகேவா? For example, இதான் train data. We are taking maybe 4.5 years of data as training. And then the test data is your blue line. This is your test data which you want to predict. Obviously, it starts the wrong one. And it suddenly changes path after this. But maybe let's see if we can predict it. இங்க வந்து what is being predicted is a naive implementation. Where வந்து previous 2 months of data அப்படியே நம்ம predict பண்றோம். That is what is predicted here. We can skip this. But this is what we're going to use in all our examples.
So ரெட்டுக்கும் டெஸ்ட்டுக்கும் இருக்கிறது டிஃபரன்ஸா எரரா? அது ஒரு
error is what is the difference between predicted and the test data. Yes.
Okay.
ஒரு just like any AI.
ஒரு ஆஃப்செட் தெரியுது. அதுக்காக
here the predicted value is nothing but naive prediction. Just last seasonல என்ன வேல்யூ அதை அப்படியே தூக்கி போட்டுறோம். Okay, copy pasting. So for example, this values and this value will be the same. Last 2 quarters என்ன வேல்யூ இருந்ததோ அதை அப்படியே காப்பி பேஸ்ட் பண்ணிருக்கோம். This is just a simple testing காக பண்ணது. This doesn't have any model. Statistic no model is being used here. Okay.
சரி சரி சரி.
So we will follow this same procedure where we set aside some data for training and then we testing. Okay. Okay, let's put any statistic model for us to work, it needs to be stationary. Okay, then it need to work. Stationary na mean is almost constant. If the mean is almost constant na, then it is very easy to predict. Yeah. For example, a time series data for which the mean is almost constant.
Okay. So
Then you can easily predict the value, yeah, in a time series data.
mean
That
is
is what you
அதாவது where the data is output வந்து வெறும் ஒரே ஒரு வேல்யூ அப்படின்னா நீங்க சொல்றது புரியுது. இப்ப is that what you're trying to say?
So what is no? I'm trying to explain define a term called stationary.
Okay.
Only when time series data is stationary, your prediction will have very good accuracy or 100% accurate.
சரி.
Okay, that is the simple logic. So obviously we can't reach obviously this time series data, we can't reach a stationary time series. There will be some errors. இல்லைங்களா?
சரி.
Okay, but that the main idea is to somehow reach a stationary
it looks like you probably go ahead with that. We'll probably understand what stationary is.
This is bit I'll try to explain. How do you know this is stationary or not? Is using this p value. You calculate the p value of the particular time series, and the value is greater than 0 or some huge value, then it means that it is not stationary. Okay, va?
Okay.
One of the simpler always rule we always use is to differentiate the time series and then use that as a stationary one. Usually differentiate பண்ணா அது stationary இருக்கிறதுக்கு வாய்ப்பு இருக்கு. ஓகேங்களா?
Okay.
For example, here I am differentiating this time series order 1, and then for which the p value reduces hugely.
Okay. Almost
so
zero ஆயிடுது இதுல.
Almost zero ஆயிடுது. So what most of the people do is they always differentiate it, and when we want to predict it, you integrate it back.
Okay.
But
So
this
what
is
you
a
are effectively
standard
saying
technique we
is
use.
effectively you are removing the mean of the data.
Then once you plot this with autocorrelation, then you will see this value is after the value of the things after 0 or 1 is very, very low, then means this thing is almost stationary. Obviously, அங்க கொஞ்சம் values எல்லாம் very high இருக்கு அங்க. But we can consider this as a okay, somewhat stationary. Okay, so that is the main idea. You mainly to identify a stationary process, you differentiate and look at the p value and then plot the autocorrelation. Autocorrelation values after the 0 and 1, if it is very, very low, it means that it's okay, it's stationary.
Okay.
Then we can use it for our prediction. Okay.
Okay.
In the next step, what we are doing is we are splitting the data set into train and test, which is 90% of the data is for training, 10% is for testing. Nothing big there.
Okay.
But next one,
go ahead.
For example, if you plot this is the actual stock data, and this is the differentiated data. If you look at it, actually the differentiated data is almost stationary at the start, but it is somewhat to get messy towards the end. This is Tesla data, but you can clearly get it. Okay, so the value of range is from 0 to 400, but here the value somewhat reduces differentiated value.
Because you are encoding only the difference, இல்லையா?
Yes.
We are only maintaining like pastல இருந்து currentக்கு எவ்வளவு டிஃபரண்டா இருக்குன்றது மட்டும் ஸ்டோர் பண்றதுனால you are actually removing the dependency on the past data. Past data ஓட dependency remove பண்ணி only அந்த error மட்டும் நம்ம plot பண்றோம்.
Yes, very good explanation. So now we have used based on this again, one more important thing from this autocorrelation is that using this value we can find out what is the order of it. If the value of the values go down after 0 or 1, then you can use it as an order also. இங்க 1 or 2 யூஸ் பண்ணிக்கலாம்.
அதாவது probably இது இப்ப you are putting the autocorrelation for the differentiated data.
Differentiated data தான் நம்ம எல்லாமே predict பண்ண போறோம். Now differentiated data எல்லாத்தையும் predict பண்ணிட்டு when you want to predict for the actual data, we will integrate it.
அதேதான். புரியுது. So அப்ப அந்த differentiated data வச்சு first prediction so you are predicting the errors. and you will add the mean at the end. And the mu first add பண்ணோம்ல, so the mu will come later.
Very good, very good. Here we are trying to predict only the close difference. What will be the next difference? அவ்வளவுதான். Then using the difference value, we will actually predict the stock value, which is just add the values இல்லையா? அவ்வளவுதான். நீங்க டிஃபரன்ஷியேட்டருக்கு மைனஸ் பண்ணிக்கிறோம், அங்க கடைசில ஆட் பண்ணிக்கணும் அவ்வளவுதான்.
புரியுது.
ஓகே. So இந்த மூவிங் ஆவரேஜ் வந்து நம்ம வந்து கால்குலேட் பண்ணி பார்த்தோம்னா will plot the values actually. Plotting only the moving average value for the last 2 quarters, last 10%. Actual value வந்து இது in blue. This is the test value, actual value. Last ன்றது வந்து we are using a simple method. Take only the last value அப்படின்றது. Just
நேத்து பண்ணதை இன்னைக்கு அப்படியே ரிப்பீட் பண்ணுன்ற மாதிரி.
ரிப்பீட் பண்ணுன்றது வந்து will almost give you a very good error இல்லையா? And MA2 is we are used order of 2. யூஸ் பண்ணி MA வந்து மூவிங் ஆவரேஜ் பிளாட் பண்ணி பார்த்தா இட் இஸ் ஆல்மோஸ்ட் லைக் a straight line. அந்த ஆவரேஜ் அப்படியே மீனா மெயின்டைன் பண்ற மாதிரி இருக்கு.
இது வந்து you are plotting the error from actual இல்ல you are plotting the
we are plotting the close dip தான் இங்க differentiated value only. Okay, obviously this is actually not a stock value.
So your MA2 is almost predicting it pretty good.
MA2 is almost predicting like a straight line. It is not looking at any of those differences. It thinks that it's almost the same value. It's not doing very good job.
So okay.
Predicted value வந்து ஆட் பண்ணோம்னா அதை இன்டகிரேட் பண்ணிக்கலாம். அந்த இன்டகிரேட் பண்ணதை வந்து நம்ம பிளாட் பண்ணி பார்த்தோம்னா இங்க என்ன மீனா இருக்கோ அதை அப்படியே கண்டினியூ பண்ணிருக்கு வித் சம் எரர்ஸ். ஏன்னா MA2 தானே, வித் சம் எரர்ஸ் வந்து இது அப்படியே கண்டினியூ பண்ணிருக்கு. திஸ் இஸ் நாட் அக்யூரேட்லி ப்ரெடிக்டிங் தி வேல்யூ. ஜஸ்ட் அந்த